very pleased to be here. This is my first webinar, so I'm a bit excited about how the process will go. So I will be talking about logging, and I'm a backend developer. I have been developing systems for about 10 years now, backend systems for 10 years, and I've been using logging my whole career. And at the moment, for the last year or so, I've been working at Humio. Humio is a new log management tool. A lot of my experience comes from before Humio, and I also have a lot of experience, which is something I've gathered while I've been at working for Humio. So I will use Humio to demo some of the things I talk about, but it won't be a product presentation as such. But I'll be happy to ask any questions afterwards. So just let me begin. So first, why is it that we want to talk about logging in the first place? So when we build systems, it's kind of like a black box. We need to make them observable. Otherwise, we don't really know why systems or how they work, if they're working correctly. So having observable systems is what makes us, which enables us to discover problems when they happen, or maybe before they happen, fix problems when they do happen. In general, understand what happens in the system, understand the user, how does the user behave, audit who does what on the system. Some systems are sensitive, contain sensitive data. There's also reporting and forecasting. So there's all sorts of needs for why we want to observe systems. And again, to kind of give the foundation here, the central ways to make systems observable is either through log events or logging, metrics, and also just black box polling, similar to, like, if some of you people know Nagios, it's an old monitoring system. So in that style, what you take with all these events and data is that you centralize them, and then you can use them for monitoring, alerting, and dashboarding, and drill down and analysis. That's kind of the foundation. And also, I want to kind of, I have seen people being a bit confused about when to use logs and when to use metrics, and there seems kind of similar. So here's kind of a setup of what's the differences between logs and metrics. So in the basic, logs are events, and metrics are aggregates of events. And there's a very key distinction here. It is that metrics are actually made from events. So you can go from a set of events or a list of events, or a list of logs, and create metrics, but you cannot go the other way around. So logs or events are in that way more fundamental. Logs tend to have a higher dimensionality, or high dimensionality, while metrics have a low dimensionality, which is also why it's metrics are aggregates of events. So you kind of, you remove stuff when you aggregate. Logs tend to be unstructured. They can be structured, but they tend to be unstructured. Metrics are more structured. Logs are very good at drill down and analysis after the fact. Metrics are very good at building dashboards and doing alerting. Logs vary in volume. Metrics have a fixed volume oftentimes, and logs tend to be high volume and metrics tend to be low volume. So it's not that logs are better than metrics. It's more of a what use case do you have. But given that you can create metrics from logs, if you can afford it, I would prefer having logs. That's my experience. And so I'm a bit unsure how many of you actually know about log management and use logging in general. From a list of attendees, it seems like there's a lot of software people here. But just very briefly, the general architecture of a log management system is that you have a set of backend systems to the left here. You install an agent, a log shipper that can ship logs to a central log management system. and then the user can access all the logs in one place. And the whole point of doing log management is that instead of going out to 10 different servers and trying to figure out what's happening, you centralize the whole thing and just need to look one place across everything. So if we just, like, say, if you look at log management from the user's perspective, the software developer that needs to look at his own logs. So I have a small demo here for, well, I'll use Humio. Let me just switch here. So what you see here is Humio. This is in many ways similar to many other log solutions. So you have a search bar here where you can enter a search query. You have a list of all the logs. If you click on one log here, you can see that a given log will have a number of fields that you can see. So this particular thing you're seeing here is actually our tutorial in Humio, and I'll not run through the whole tutorial. I'll just kind of pick some of it just to kind of get a feeling of what is a log management system. So let me click here. So the data here is an access log. So you can see there's a web request here, a person on the whole thing simulated that this is fictive data. There's an IP address, there's a URL, there's a timestamp, there's which type of HTTP request was this. Look here, there's a number of other fields. So the basic thing in the log management system is that you can just type in words and then you'll filter that. So now I'm finding all the logs or all the access logs here that contains the example.com string. I could also say, what about get? So now I'll get all the example lines containing example, and also get. If I say not get, then I'll get all those that don't have get. So see, this is a post now. So basic filtering, let me just see if I can find my way back here. So basic filtering is kind of the bread and butter of log management systems. But there are two things that are really, very key when you work with them. One is group by, and the other is plotting, making time charts. So for example here, if I say group by method, the query will count the number of events per HTTP method. So if you look at the events below, behind it, so each event has a field here that says this is a post method, and then we can group by that field. So what this query here is actually just a shorthand for saying that let's just count. So we take the field method and then we count all the occurrences of events with that. So the other thing that is very oftentimes used is time charts. So let's see, what do we have here? Just jump to another one. This is a bit more advanced example. So what's happening here is that we are saying that the status code of the web request needs to be smaller or equals to 400. The URL needs to be something starting with products, and then we take this filter and then we pipe it using the pipe command, and then we're time charting the status codes as the series. So what we're seeing here, and then this is running live, so this is the last 5 minutes. So now we're seeing all the different status codes as they occur and how many there are. So I actually also think this query here is stacked. We can also kind of tweak how we want to present it. This ability to just drill into your data and make sense of it is very key. and what really makes log management a benefit. I'll present some more advanced queries later. This was just giving you a very brief tour of a log management system. Yeah, actually, some other key areas is that it's very nice to be able to follow the tail. So if we just remove the time chart, so now this is just giving me the stream of events as they come in within a couple of seconds. I can also say, like, what if I want to see things that are errors? So I could say status code equal 500. So you could imagine. So now this is all so the data behind this is simulated. So there's a lot of errors all the time. But you could imagine you're doing a deployment of your site, being able to follow your system while you're deploying and seeing if you're getting a lot of 500 status codes. 500 means that there are some kind of server error. Is very beneficial. You can throw stuff like this on the dashboard, and you can also do alerting. I'll not jump into that at the moment. So this was just a very the basic. So I've kind of thought about what is it that makes logging. What is it that makes? How do you get most value out of your logs? Well, there's one really key thing to having good logs, and that is that you should start read your logs. And this is sounds a bit silly perhaps, but it's actually the key point here is that in my experience there's a lot of software developers that have a backend system that doesn't really look at their own logs. So they know the logs, they create log statements, but they actually don't read them. And that means when something is down and the stuff isn't working in production, the logs they have is not really helping them because it's the wrong logs. The only way to get some logging infrastructure that really works is by using your logs. So actually, if you should remember one thing from this presentation is that you should start reading your logs if you don't already do that every day. And as soon as you start reading your logs, you'll discover that logs evolve. There are two reasons why logs evolve. One is that every time you do changes to your system, change business logic or add new modules, you'll also add new log statements or delete or change them. So there's kind of an outer loop for doing that. But when you start reading your logs, you'll also discover that you need to instrument your code better. So you start doing changes that are only because you need better instrumentation. You need to make the system more observable or being able to be observed in a better way, getting better stats. So the whole thing about working with logs is very much a cultural thing, and it is key to start improving your logs and getting rid of those that don't create value. Another aspect of log management is how to get logs into your system, into your log management system. So my best advice here, if you're starting out, is to start simple. Setting up a complete log shipping pipe or log pipeline can be tricky. Some of the reasons for this is that all systems log in different ways, and getting logs aligned across many different types of systems, so web servers, OS logs, metrics, application logs, database logs, is a big task. So start small and get something working. So log shipping tends to come in two different categories. There's like I would say not the old way to do it, but the traditional way to do it is to log your system will log to a file on your operating system, and then you'll have an agent that forwards your logs from that file. The other strategy is to have a logging module in the application that will just ship logs directly. So there's benefits and consequences of both of those. So having logs locally means that you can debug them locally, which can be a huge benefit. If, for example, your whole pipeline is falling, which can happen when you have failures in your systems. It also log shippers that start from files tend to enable or have better delivery guarantees. So if they cannot deliver the logs now, it will try again in 10 seconds or half a minute. Setting up a log library directly tend to be more easy, I think. But the downside is that it's often fire and forget. So if you can't deliver your logs, you will mostly lose them. There are a number of log shippers out there. And I have experience with these three, as you see here. These are all open source tools. Beats and Logstash are both being built by Elasticsearch. Elasticsearch is a text database that is also very often used for logging. So actually, in Humio, we use the open source tools available for log shipping. We haven't built our own. And I have had really good success with the beats, which are the new agents that Elastic are building, especially FileBeat if you're sending files. FluentD and Logstash are more complicated. They can do a lot of stuff. If you don't need to have a complicated, I would advise to aim for a simpler log pipeline if possible, and if you can avoid using FluentD or Logstash. In my experience, that makes it easier, but sometimes that's not possible. FluentD and Logstash can do a lot of stuff in terms of organizing the log pipeline, but it comes with complexity. Another thing about log shipping, or something that's relevant to log shipping, is orchestration. So one of the things that makes log shipping hard is that there's very big variety of data sources for logging. If you start going into orchestration such as Kubernetes or Mesos or Docker containers, then that kind of gives you a platform, and many of these tools have hooks into to logging, which makes logging to some degree much simpler, because they have, like, normally from a container, standard out is what you log. There's one downside here, is that some of the context that is orchestration or platform specific, like in Docker, a container ID or a container name is something that is owned by Docker, can be a bit tricky to get into your logs. It doesn't come out of the box yet. There's still some standard ways to do stuff that needs to be done. So setting up logging for orchestration can be a bit more complex. It depends. Just to illustrate how the log pipeline looks in terms of when you have orchestration, is that normally, instead of having an agent per OS or host or application, you'll set up logging once for the whole at the infrastructure layer. At least that's what you should aim for when you use, for example, Kubernetes. Many times there's a team that's responsible for the infrastructure, and there's a team that's responsible for creating a set of given services, business services. And when creating new services, it's a really big advantage if the people creating new service doesn't have to touch the infrastructure. So they're not depending on the infrastructure team changing, for example, FluentD configurations or log shipping configurations. That would be being self-servant in this regard. In regards to logging, makes people use logs more, which is, at least from my perspective, what you want, because otherwise, again, you won't use your logs to the fullest. Okay, so the different thing is, so how do you actually create better logging? So every log is part of a workflow, and logs from a workflow should tell a story. So example of workflows is you start a new service and it lives for a number of days, and then you shut it down and replace it with a new version of the service. That is one workflow. Another workflow is a web request. So kind of capture IDs of a workflow and being able to follow that workflow will give your will actually tell your story. So here is a screenshot. This is from a web system. So I narrowed down the search to a given request ID, and you can see I found 11 logs. And the story here is that a user did a web request to this web system. This is a conference system with this URL. So this was the path. It executed, I think it's 9 SQL statements to the database. And then it was logged that the whole request took 41 milliseconds, and it returned status code 200. So you see, this is a small story about a workflow that the system performed at a specific time. And from here, you of course get a bit curious. So okay, let me go back. So this took 41 milliseconds. So what about in general? How long time does it take to execute or to run the requests? So here I did another query. So here this data sent 241 milliseconds. This is unstructured. This is just a piece of text. So in Humio we can expect or structure things from regular expressions. So this is a regular expression that matches all events that says send 200 in, and then some value, and then MS. And then I capture the number in the time field so that I can use it to plot. So here I plot a time chart using the percentile function, and I give the 19th, 95, 99, and the hundredths percentile. So immediately seeing this graph, some things make you more curious as well. So the 90 percentile and 95 percentile seems okay. It's under 200 milliseconds, and then there's a lot of spikes, and those seems to come every hour. So this is a bit. I haven't looked into why it is such, but having the ability to just plot your data immediately, you can see some patterns here. There's something running once in a while that takes more time than the rest. So this is a logarithmic scale. So it's like this is like 10x. The maximum latency is 10x above the low percentile here. Another thing that this is an advanced query. Again on the same data. Go back. You can see there is a lot of select statements, and there is a field called dB equals and then some latency measure. This is the time it took to do the SQL statement. So one thing you could ask yourself is which SQL statement is actually the one that is loading the database the most. So if we start with the result here, I've taken the 5 heaviest SQL statements in terms of the total runtime they have within the last 24 hours. For this particular SQL statement, the database has spent 32 seconds running that. So this is not a database that is heavily loaded, but this is the heaviest loader, if you wish. So it was called 8,000 times, and the average latency was 3. We have the second URL is called 140,000 times, so many times more, but the average latency was much smaller. So this is less of a load factor. So the way I actually found this was that I did again a regular expression capture group. So I selected all the literal SQL statement here and put that in a capture group called Q for the query. I also captured the value part of the latency, so skipping the MS so that I can do calculations on it. Then I do a group by over all the literal SQL statements. I find the max time in the interval, which is 24 hours. I find the average time, and I count the number of times this SQL was run. Then I calculate a total by multiplying count and average. Underscore is the default name for running the count function. And then I rearrange here with a table function so that the query goes all the way to the right, because it goes way out of the screen so that I can see the other fields. And then I sort by total and limit to a 5 node. So having a log management system enables you to very fast drill down into your data and get answers to questions you didn't know you needed when you did the logging. And this again comes back to the high dimensionality in logging compared to metrics, which I would imagine if you had you would often have a metric on how long time queries take on the database. You might not have the little SQL statements in your metrics, so you wouldn't actually be able to perform this on if you only capture the metrics. Of course, you could capture the literal SQL as well in metrics, but oftentimes, if you just capture metrics and not logs, you'll have less context to work with. That leads to context. So workflows kind of, if you go back here, the workflows kind of tells you a story of which story the log came from. Context to the given log gives you all the fields or all the dimensions from which you can expand your drawdown. That includes like IDs, user information, where it came from, all the platform-specific things like host, pod, task, container names. Here's another screenshot. This is from a Kubernetes system. So here, using FluentD can, for Kubernetes, set up a lot of context. So these are all the fields that comes from free from just running from Kubernetes. So you see the container name here. This is the front-end service. That's the host it's running on. There's some, there's a label, there's a URL, there's a namespace. And all this is captured automatically when you set up log shipping for this. Different log management systems have different ways of doing that. In Kubernetes, I think most will use FluentD because it does some of that for you. But setting up a pipeline that adds context for orchestration tools is I think, many times depending on the log management tool you're using. So we have one for Humio, and another log management tool will have other ways of doing it. Which is actually a shame, I think, because this should be part of the orchestration tools themselves, and not something that, because this is, like if you're talking object-oriented programming, this would be private data in an object. It shouldn't be something that it's kind of, we're breaking the boundary here. An ID should be something that the orchestration tool handle, not some outside factor. Okay, that's a side note, sorry, but yeah. And then last, I will just give a mixed bag of notes and tricks. I've been struggling with log levels, I think, my whole career. What does debug, info, warning, error, fatal mean? And I've come up with my current way of seeing this is that there isn't any clear definition. What I'm working with when I work today is I very seldom use debug. Everything is info. Warning is something that a developer or administrator should look at some point, maybe the next workday. This is something that's out of the ordinary and needs kind of looking into. Errors for when I use that is mostly means that there's something here I don't understand. This was a path in my new module that I didn't expect would get exercised, and I didn't know how to handle it correctly, and I'll throw an error because, yeah, I'm not completely sure. That's basically what it means. And I think that's how it is for many people. And that gives, of course, the opportunity to, when you see errors, that you should fix them, look into them. And often when I do that, the error will turn into an info. There's a lot of things that I think are illegal or shouldn't happen. That happens all the time, especially when you talk to third-party systems. They can do exceptions in all sorts of strange ways all the time. Fatal would be something that you trigger an alert on. Actually, I would mostly trigger alerts on metrics, either generate from logs directly or having metrics directly in your systems. And it would be high-level metrics, such that the amount of requests to your website is 0. You normally have like 1,000 requests per second. Now you have 0. That indicates strongly that something is very wrong, or your cash flow is halved compared to what's normal. That is a very strong indication that somebody should be woken up. In most systems, if you start waking people up, as soon as you see an error log, people will be awake all the time. At least that's my experience. Another thing that I think people struggle with is with log. Which types of log format should you use? A lot of people use JSON. JSON is very good because it contains a lot of structure. You don't need to parse it later. It just comes for free. That's very good if you have control of how you log. A lot of legacy systems or existing systems, like a database, maybe doesn't support JSON. So it's not something you can control all the way through. Another aspect of JSON is that if you are doing looking at logs locally on the server, then JSON can be more difficult to use manually. You need to, there's a tool called JQ, which is very good at inspecting JSON data, and so you need to use new tools to look at JSON logs. The log format I usually use is one like this. So you have a log message, then you have key equal value pairs for the rest. So this is fairly easy to read by humans, and it's fairly easy to parse by machines. So for me, this is a good mix of both of them. Another thing I see often is that metrics is siloed next to logs. So again, if you look at a Kubernetes or system, then there's, from what I see, a tendency to have metrics in Prometheus, for example, and logs in Elasticsearch, which is all fine. And then they kind of join them in another tool for dashboarding. Having both the metrics and the logs in the same place makes it much easier to correlate and drill down. So you can see when your number of requests goes down, was it at the same time as you deployed a new service, or that a certain set of errors happened, or a third-party provider was crashing or such. So I would try to put metrics and logs together. Oh, and a good tip here: as soon as you start a new service or a new system, put in the Git hash or whatever hash you have in your source code repository, of what version it is, so you know exactly which version is running, and also put all your config, the whole config of a given system in that same log. I've wasted a number of times debugging the wrong code or the wrong configuration, and having it very clear in the first log, or one of the first logs when you boot a system, which source code entry or which version is this tied to Git hash, or which configuration is this given service using, is key. And last, I've always been following my deployments with the tail. So do a filter that finds all your shutdown logs, all your startup logs for a given service, and then all the error logs that could happen, or all things that show you if things are wrong, and just have that running as a tail, or just follow the tail in live. You should have a log management system that can give you those within 5 seconds, something like that, and set up a log pipeline that will push data through with low latency, so that you can follow your deployment as it comes in. At least that works very well for me. So thank you very much for listening. There's time for a lot of questions if you have questions. And if you feel free to ask anything about log management or Humor, and you can go to our webpage if you're more interested in Humor, or if you have questions for me, you can send me a mail here. So yeah, I'll take a look at questions. Okay, let me just navigate this. So there's a question here. How does Humio compare to all log management solutions? Yes, so we are we have focused a lot on making the experience of just drilling down into the data very easy, and getting the interactive feedback loop running very fast. And also, if you do aggregations such as group bys or time charts or more advanced stuff, being able to do that more or less on the fly using a methodology that is known to a lot of people, namely the piping commands together, similar to a Linux pipeline, is key. I think we have succeeded with that. At least that's what we're hearing. Another aspect where we differ, I think, to many other solutions is that we're streaming to the core. Maybe I can show that. See if I can have a test system here, which is like we have a query here that so this is actually GitHub data running here. It's a live GitHub data as it comes in, so they have an open repository. So I can say like group by type. Go. So now I'm counting the types of events coming into the system as they come. And it's updating on the fly. I can sort this. And then I sort the count. So a group by is essentially also a bar chart. So we can change the visualization here. And now we have a bar chart. So this is all streaming. I can also do a pie chart. This is still just streaming. And if I do a time chart, it's also, let me just pretty that up a bit. Put that on top of the chart. So now this is basically just giving you a view of all the types of events coming into the system as they come. Yeah, another aspect where we differ from a lot of other solutions is that Humor is both on-prem and managed. There's a lot of managed solutions for log management. There isn't that many on-prem. So I hope that answered that question. Is there any other questions that people have?
I think that seems to be all for questions. I'll give us a couple more minutes just in case anybody comes up with some more. And then if not, then if you have come up with any questions later on, you can either email them to myself and I can forward them over to Peter.
That's just fine. Or just send me a mail directly.
There doesn't seem to be any more. So thank you all so much for joining the session. What I'll do is I'll send you all a recording of the session as long as my email and Peter's if you have any questions. Thank you so much.
Thank you.